For more than 200 years, humanity treated Uranus like an afterthought. It was the pale, silent at the edge of the solar system, the planet astronomy teachers rushed through on the way to Neptune. Even NASA seemed to lose interest after a single flyby in 1986. But that changed the moment the James Webb Space Telescope turned its enormous mirror toward that quiet blue world. What it found was not a boring gas ball drifting through the dark. It was a planet with a shattered magnetic field, storms hiding under a deceptive haze, rings that shouldn't glow the way they do, and an interior so violent that scientists believe it may be raining diamonds hundreds of miles beneath the clouds. The sleepy planet nobody wanted to study turned out to be one of the strangest, most dangerous worlds in the entire solar system. To understand how unsettling these new images really are, you have to go back to the last time humans got a close look at Uranus. In January 1986, NASA's Voyager 2 probe swept past the planet on its way toward Neptune. It had one shot, a matter of hours, to gather everything it could. The pictures it beamed home showed almost nothing, a smooth, featureless blue-green sphere with barely a cloud in sight. For decades, that single flyby became the entire public image of Uranus. Textbooks called it the most boring planet in the solar system. Mission planners at NASA repeatedly passed it over in favor of missions to Mars, Jupiter, and Saturn. Uranus simply didn't look interesting enough to justify the cost. That reputation turned out to be built on almost nothing. Voyager 2 arrived during a narrow window, saw a narrow slice of the planet's 50-plus-year seasonal cycle, and left. It never had the instruments or the time to look beneath the surface haze. When the James Webb Space Telescope began observing Uranus in infrared light, wavelengths completely invisible to the human eye and largely inaccessible to Voyager's cameras, an entirely different planet emerged. Bright polar caps, sharp, structured cloud bands, a tangle of glowing rings, storms bubbling up from deep inside the atmosphere. The boring planet had simply never been looked at properly. The story of how we found Uranus in the first place is almost as strange as what we're learning now. Every planet visible to the naked eye, Mercury, Venus, Mars, Jupiter, Saturn, had been known since antiquity. Ancient civilizations tracked them across the sky for thousands of years. Uranus broke that pattern entirely. It sits so far away and moves so slowly that it took a telescope and a very determined observer to notice it at all. That observer was William Herschel, a German-born musician and amateur astronomer living in England, who had built his own telescopes by hand and spent countless nights mapping the sky simply because he found it fascinating. On the night of March 13th, 1781, he spotted an object that didn't behave like an ordinary star. At first he assumed it was a comet. It took months of follow-up observation and contributions from other astronomers who calculated its orbit before the scientific community accepted that Herschel hadn't found a comet at all. He had found an entirely new planet, doubling the known size of the solar system overnight. Herschel initially wanted to name his discovery Georgium Sidus, the Georgian star, in honor of England's King George III. Other European astronomers weren't fond of naming a planet after a British monarch, and eventually the name Uranus was adopted instead, drawn from the ancient Greek god of the sky, keeping the tradition of naming planets after mythological deities. It's a fitting name for a planet that would go on to defy nearly every expectation we had for how a planet should behave. The single strangest thing about Uranus isn't hidden in its atmosphere or its rings. It's written into the way the planet spins. Every other planet in the solar system rotates in a manner that at least loosely resembles a spinning top, tilted slightly on its axis. Earth's own modest 23-degree tilt is responsible for our seasons. Uranus obliterates that pattern. Its axis is tilted by roughly 98 degrees, meaning the planet doesn't so much spin like a top as roll like a ball across the floor, orbiting the sun almost completely on its side. Its rings and moons orbit along with that sideways tilt, forming a bizarre bullseye pattern rather than the flat disk we're used to seeing around Saturn. Scientists have long suspected that this extreme tilt is the scar left behind by an ancient catastrophe. The leading theory holds that early in the solar system's history, an object roughly the size of Earth slammed into Uranus with enough force to permanently knock the planet onto its side. Billions of years later, the planet has never recovered. It's still tumbling through space, carrying the memory of that ancient impact in every rotation. That tilt does more than make Uranus look strange in photographs. It completely rewires the concept of day and night on the planet. A single day on Uranus lasts about 17 hours, which sounds almost Earth-like. But a full year, one complete trip around the sun, takes roughly 84 Earth years. Combine that slow orbit with the planet's extreme sideways tilt, and you get something almost impossible to imagine. One pole of Uranus can spend over 2 decades in continuous daylight, while the opposite pole spends that same span trapped in unbroken darkness. A person could theoretically be born at the start of a polar night on Uranus and reach adulthood before ever seeing the sun rise. And even that sunlight, when it finally arrives, isn't much to speak of. Uranus orbits nearly 1.8 billion miles from the sun, roughly 19 times farther away than Earth. Sunlight takes almost 2 hours and 40 minutes just to make the trip. By the time it reaches Uranus, it's a dim, cold whisper of the light we experience here. It's against that backdrop of weak sunlight and decades-long seasons that Webb's new images become so remarkable. Pointed at Uranus's north pole, the telescope captured a brilliant, glowing white cap stretching across the top of the planet. Not a passing weather event, but a massive seasonal structure tied to the planet's brutally long seasons. Near the edge of that bright cap, Webb picked out a darker band, evidence of real internal structure rather than the smooth, uniform haze that Voyager 2 once suggested. Uranus is currently approaching its next solstice in 2028, the point where one of its poles tips most directly toward the sun, and Webb has essentially caught the planet mid-transformation, its polar cap brightening as more sunlight reaches that hemisphere. Just below that polar region, Webb also spotted bright storm activity churning in the atmosphere. These storms don't come close to the raging, centuries-old superstorms we associate with Jupiter's Great Red Spot, but their presence alone shatters the old idea that Uranus is atmospherically dead. Ground-based observatories, the Keck Observatory, the Gemini telescopes, and the Hubble Space Telescope had already started chipping away at the myth of a featureless Uranus over the past 2 decades, tracking clouds that brighten, shift, and dissolve. Webb simply delivered the sharpest, most conclusive blow yet. Even the planet's signature pale blue-green color turns out to be something of a disguise. That hue comes from methane gas high in Uranus's atmosphere. Sunlight passes through the outer layers, reflects off deeper cloud tops, and travels back out toward space, but methane absorbs much of the red wavelengths along the way. What escapes back into our telescopes is mostly blue and green light, giving Uranus its calm, almost gentle appearance. That serenity is a trick of chemistry, not a reflection of what's actually happening underneath. Beneath that soft-colored haze, Uranus's atmosphere is anything but peaceful. Wind speeds can reach roughly 560 miles per hour, among the fastest sustained winds recorded anywhere in the solar system. Stranger still, those winds don't even agree on which direction to blow. Near the equator they move against the planet's rotation, while closer to the poles they shift and flow with it. Layered on top of that chaos is a cold that goes beyond simple distance from the sun. Temperatures in Uranus's atmosphere can plunge to around minus 372 degrees Fahrenheit, colder than any naturally occurring temperature ever measured on Earth. What makes this especially strange is that Neptune, which orbits even farther from the sun than Uranus, is often not as cold. Neptune generates a substantial amount of internal heat that helps drive its dramatic storms. Uranus, for reasons scientists still don't fully understand, radiates barely any internal heat at all, leaving it colder in places than a planet that sits deeper in the darkness of the outer solar system. The atmospheric chemistry gets stranger the closer you look. In 2018, astronomers using the Gemini North Telescope in Hawaii detected hydrogen sulfide, the same compound responsible for the smell of rotten eggs, in Uranus's upper cloud deck. It's an almost comical detail for such a forbidding place, but it carries real scientific weight. Jupiter and Saturn's upper clouds are dominated by ammonia ice, while Uranus's cloud chemistry runs differently, one of the key distinctions that separates the solar system's gas giants from its ice giants. Not that the smell would matter to any visitor. Long before hydrogen sulfide became a problem, the crushing pressure and unbreathable, deadly cold of Uranus's atmosphere would end things for any spacecraft or living creature unlucky enough to descend into it. Rings are usually the last thing anyone associates with Uranus, largely because Saturn's rings are so spectacular that they've claimed the public imagination entirely. But Uranus has rings too, 13 of them, discovered almost by accident. In 1977, astronomers were watching Uranus pass in front of a distant star, expecting a single clean blackout as the planet blocked the starlight. Instead, the star's light flickered off and back on several times before the planet even reached it, then repeated the same flickering pattern after the planet had passed. Something invisible was blocking the light in a repeating, structured way. That something turned out to be a system of narrow, dark rings, invisible from Earth until that chance alignment revealed them. Webb's infrared vision has now captured those rings with a level of clarity earlier telescopes simply couldn't achieve, including the faint, diffuse Zeta ring closest to the planet, critical information for any future spacecraft that might need to navigate safely through the debris. Interestingly, the outer rings appear to be built from different material altogether. One, tinted blue, seems to be fed by fine icy particles shed from the small moon map. The other, reddish in color, may contain dustier, possibly organic material, suggesting that small bodies around Uranus are still actively shaping its ring system today. Webb didn't stop at the rings. It also uncovered a moon that had somehow evaded detection through decades of increasingly powerful observation. Temporarily designated as /2025 U1, the tiny moon is only about 6 miles across and orbits close to Uranus's inner ring system. Voyager 2 missed it during its 1986 flyby. Hubble missed it for decades afterward. It took Webb's infrared sensitivity to finally pull it out of the darkness, bringing Uranus's known moon count to 29. Uranus's moons carry their own strange signature, breaking from the mythological naming tradition used almost everywhere else in the solar system. Instead of Greek or Roman gods, Uranus's moons are named after characters from the works of William Shakespeare and Alexander Pope: Titania, Oberon, Ariel, Umbriel, Miranda, Puck. Of these, Miranda might be the strangest world in the entire system. Despite being less than 300 miles across, its surface is a chaotic patchwork of cliffs, grooves, and craters that still puzzles planetary scientists. Its most famous feature, Verona Rupes, is often cited as one of the tallest known cliffs in the solar system, with estimates placing its height at around 12 miles, more than twice the height of Mount Everest, carved into the surface of a moon smaller than many Earth cities. As dramatic as the surface features are, the true mystery of Uranus lies in what's happening beneath the clouds, in a place no spacecraft has ever come close to reaching. Uranus has no solid surface to land on. A probe descending into its atmosphere wouldn't crash the way it would on Mars or the Moon. It would simply keep sinking, passing through thickening layers of hydrogen, helium, and methane, the pressure climbing relentlessly with no ground ever appearing beneath it. Eventually, the pressure alone would crush any spacecraft long before it reached anything resembling a bottom. Uranus is classified as an ice giant, but that name is misleading. It doesn't describe a giant frozen snowball. Instead, it refers to the materials that make up most of the planet's interior: water, methane, and ammonia, substances that would freeze into ice under normal conditions in the vacuum of space, but behave completely differently under the crushing pressure inside Uranus. Most of the planet's mass is thought to exist as a hot, dense fluid wrapped around a small rocky core, with temperatures near that core potentially reaching around 9,000 degrees Fahrenheit. It's not quite gas, not quite liquid, not solid ground, something dense, superheated, and trapped between all three states at once. Somewhere within that crushing interior, scientists believe one of the most extraordinary processes in the solar system may be taking place: diamond rain. Deep inside Uranus, extreme heat and pressure are thought to break apart methane molecules, freeing carbon atoms that can then bond together into tiny diamond crystals. Denser than the surrounding material, those crystals would sink deeper into the planet, falling like rain through a layer no human will ever witness directly. This isn't pure speculation. Laboratory experiments using powerful lasers have recreated similar extreme pressure and temperature conditions and successfully produced tiny diamonds in the process, lending real scientific weight to the idea that Uranus's interior may be quietly manufacturing gemstones under conditions violent enough to destroy anything sent to observe them. That same hidden interior may also explain one of Uranus's most bizarre features, its badly broken magnetic field. On Earth, the magnetic field behaves roughly like a bar magnet running through the planet's center, aligned reasonably close to its rotational axis. It's not perfect, but it's predictable enough to guide compasses and shield the planet from the sun's charged particles. Uranus offers nothing so tidy. Its magnetic field is tilted nearly 60 degrees away from its rotational axis and shoved almost a third of the planet's radius off-center. The result is a magnetic bubble that looks less like a shield and more like something knocked askew and left that way. Uranus's auroras reflect that same chaos. Instead of forming near the poles the way Earth's northern and southern lights do, they appear scattered across seemingly random locations, following a magnetic field too lopsided to guide them anywhere consistent. As Uranus moves through space, its magnetic field trails out behind it, twisted by the planet's sideways rotation into a long corkscrew shape stretching for millions of miles. Even our only close-up understanding of that magnetic field has recently come into question. A 2024 reanalysis of Voyager 2's 1986 data suggests the probe may have arrived at Uranus during an unusually rare period of intense solar wind activity, one that could have compressed the planet's magnetosphere down to as little as 20% of its normal size. If true, that means much of what scientists have believed about Uranus's magnetic environment for nearly 40 years may have been shaped by a single moment of bad cosmic timing rather than the planet's normal state. All of this, the storms, the tilted magnetic field, the diamond rain, the mismatched rings, the newly discovered moon, points toward the same conclusion. Uranus isn't a dull, finished chapter of solar system exploration. It's one of the most misunderstood planets we have, and possibly one of the most important. Astronomers have now identified nearly 2,000 exoplanets orbiting other stars that fall into the same size category as Uranus and Neptune, larger than rocky worlds like Earth, but smaller than gas giants like Jupiter. We can't send probes to those distant worlds. We can't watch their seasons unfold or study their storms up close. But Uranus sits right here in our own solar system, close enough that a dedicated mission could finally unravel what Voyager 2's brief, possibly poorly timed flyby never could. That's exactly why the Uranus orbiter and probe concept has been named the top priority flagship mission for planetary science in the current decade. The plan calls for an orbiter that would remain in the Uranian system for years, tracking its atmosphere, rings, moons, and magnetic field as they shift and evolve, paired with an atmospheric probe designed for a one-way descent into the planet itself, gathering data as it falls until the crushing pressure and freezing cold ultimately destroy it. It wouldn't be a mission built for survival. It would be a mission built entirely to finally answer the question Uranus has been hiding behind its calm blue face for over 2 centuries. What is really happening down there?